Hello, I'm going to just go over some of the techniques that we covered at the end of class with taking the 5 key points for a sine function or a cosine function and transforming where the location of those points are in order to make a new graph of a new function. So let me just do a quick screen share, and I'm just going to do a couple of problems from the same section from which you're doing homework as examples. Okay, so here you see from section 5.3, let me write that up here. You can see that we're doing problem number 18, which is from the same set as the homework. So we have a y equals negative sine of 2x. Now you might be able to guess what it does right away. We're going to have a flipping of the sine function over the x-axis, and we're going to have a compression of the sine function. So you might be able to quickly sketch it, but let me show you the 5-point method. So we have theta, and we have, which will be equal to 2x in this case, and we have the sine of theta. So we know from what we've done in class, we have key points 0, when the theta is 0, the sine is 0. When theta is pi over 2, the sine becomes 1. When theta goes to pi, the sine value goes to 0 again. When theta equals 3 pi over 2, we have a -1, and at 2 pi, we have a 1 again. So those are the 5 key points for the sine function. Now, if I want to go forward, I know that y is not equal to the sine of theta. Y is equal to negative sine of theta, because remember, theta is 2x. So that's a pretty easy transformation. These can just switch signs. Whoops, and that was supposed to be a 0. So that stays at 0. Okay, so we have the negatives of the y values, and that's exactly what the negative in front of the sine function would do. It's a vertical change. It's a flip over the x-axis. All right. Then we have what happens. We know what 2x is supposed to be. If 2x is equal to the values in the column for theta, then we want to figure out what x is. Well, how do we get to x from theta? It's going to be half of the theta value. So if theta equals 2x, x is equal to half of theta. So what is half of 0? It's 0. Half of pi over 2 is pi over 4. Half of pi is pi over 2. I could call that 2 pi over 4. That might be helpful. We'll see a pattern here. And half of 3 pi over 2 is 3 pi over 4. And if I want to, then 2 pi divided in half would be 4 pi over 4, or just pi. Okay. So if I want to graph this, what I would do is now just draw some axes. So I will draw an axis here, and we can mark it off where here's, let's make pi right here. Okay, and negative pi will be 1, 2, 3. I'll do 4 units the other way. So what I need to plot are the x coordinates versus the y coordinates. Okay, so my new x coordinates are 0, pi over 4, 2 pi over 4, 3 pi over 4, and pi, and then my y coordinates are on the far right. So that's what I will graph. Okay, so for one cycle, I can plot the point 0, 0. We do these in red. So I have the point 0, 0. Oh, and let me make tick marks. That'll be 1. This will be -1. Okay, at pi over 4, that'll be my first line. I'm down at -1. At pi over 2, that's halfway there. That's where I'm going to be at 0 again. And then I'm going to go up to 1 at 3 pi over 4. By the time I get to 4 pi over 4, I will have a graph that looks like this. Okay, and then you might want to just take a pencil and lightly sketch in what this looks like. And when that looks good, you could ink it in. So back to my pen, and that looks pretty good. So that gives me a guide, and I can ink in what one cycle looks like. Now I could keep going forward. If that's one cycle, there's going to be another cycle continuing forward, and I could keep going backwards. Put a few points on here going backwards. Okay, and if I ink this in going backwards, because in this part it says draw what the function looks like. Now it would be helpful if you compare that to what the sine looks like. The sine from 0 to pi would look like what I have in blue, and if I kept on going, it will do something like this. And if I draw that in the other direction, we're going to go down to a value of -1 here and back up. Okay, so it's going to look something like that. So you can see that this is oscillating, the red graph is oscillating twice as fast as what the sine function would have looked like in that same domain. And it is the red graph, instead of the blue graph, goes up first, whereas the red graph goes down first. Okay, because it's a flip of it. Okay, so we can flip over the sine function and then compress it, or we can compress and flip it. It doesn't matter because the horizontal and vertical changes are independent of each other. So that's what that one would look like. Let's move on to number, we'll just do number 20 because it involves a cosine. Okay, y equals 1/2 cosine of 4x. Okay, so let's do a similar thing here. We'll make our little table. We'll have theta, which will be equal to 4x in the middle column. Okay, and we'll have, in this case, we better do the cosine of theta. And then we're gonna leave a little space here. Okay, and let me just make a line and another vertical line. Okay, and then we need to go forward from here. So for cosine, the values, the key values will be 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi will go all the way to back up to 1 again. So that's what the cosine function does. Now, as we go forward, we switch to red, we just need 1/2 the cosine of theta. That's what our y value will be. So y will end up equaling 1/2 cosine theta. So just take all of these and divide them in half. Okay, so those will be the y values that we need to plot. That's pretty easy. Okay, trickier thing is the x values. So remember, x will be theta over 4, right? So these will be the x values. So let's divide them all by 4, and this becomes pi over 8. Okay, and then this becomes pi over 4, or 2 pi over 8 if we wish, 2 pi over 8, just to keep the units all the same. And then the next one will be, let's see, we have 2 pi, this will be 3 pi over 8, and then we end up having 4 pi over 8. We do the last one. So if we do them all in 8s, it might be a little bit easier for graphing. Okay, so now I need to graph this. These are my x values and y values that are going to get paired up. So always just look for, the x-y combination. Let me make a quick graph right over here. Let me move that line down. Actually, let me delete that in. Let me do a better job drawing that line. There we go. That's much better. And let's see, we're supposed to do multiple cycles for this one. But let's just go something like that. Okay, and so we're doing this by 8s. So we divide it by 4. So there's 1/8, 2/8, 3/8. Here will be 4/8 pi, or pi over 2. All right, and we can go backwards 1, 2, 3, 4. That's negative pi over 2 if we went backwards. Okay, so in going forward, let's now plot the points. Okay, so 0, 1/2. Oh, let's put 1 up here again and -1 down there. So 1/2 would be right in the middle. 0, and then we have pi over 8, 0. And then we have 2 pi over 8, -1/2. And we go back up to here and back up there again. Whoops, I'm sorry, down to there. So let me erase that point that I put up there, too high up. I'm going to pencil in a curve. Okay, just lightly, looks something like that. It doesn't look bad. And then it's going to go backwards and kind of do the same thing in the backwards direction. So I'm just kind of sketching it in pencil. That looks pretty good. So I'll go in and ink it in now. That's roughly what it would look like. Now let's compare that to a cosine graph. Remember, the cosine would have been up here, starting at 1. By the time we get to pi over 2, it's to 0. So the cosine graph would have been like that. Would have looked something like this. Okay, so this is oscillating 4 times faster than the cosine function, and it's half as tall as we would expect. Okay, so that's what that would look like, and we did that with our 5-point table there. Okay, let me just do a couple more of these. So let me switch over to, I'm going to go right to number 34. Actually, I think I'll make this my last example. So number 34, y equals the sine of 1/2 x plus pi over 4. So how would our 5-point method work for this? Okay, so let's just start by making a little table right here. Theta will equal x plus pi over 4. Oh, I'm sorry, theta is actually, go back, it has 1/2 in there too. So I better start a little bit further to the right. I'm going to need to make 2 changes. So, oops, I keep trying to write with my eraser. I think I've got it now. So that's theta. And then I need to be able to do the sine of theta. And I'm going to need to have a lot of room to the right there, but actually not too much room to the, I'm sorry, a lot of room to the left. I don't need too much room to the right now. Okay, let me just put my column line down here. All right, so we have 0, pi over 2, pi, 3 pi over 2, and 2 pi are the key points. And we know that the sine function is going to be at those values, let's see, 0, 1, 0, -1, 0. Okay, so we can fill those in pretty quickly. Now, if you look at it, we don't need to make any changes vertically. Okay, all of the changes in this problem are on the inside of the argument of the sine. Technically, they don't show it, but you could think of there being an extra set of parentheses right there. So we don't do anything to the sine function once we use it. So the y values are the column that we have right here. We don't need to go to the right at all. But we do need to go backwards in 2 steps, okay? So the first thing we need to do is find out what x plus pi over 4 would be, which would be 2 theta, okay? So x plus pi over 4 is equal to twice theta. So let me draw a vertical line in here. Okay, so if I were to double the theta values, I'll get 0, pi, 2 pi, 3 pi, and 4 pi. Okay, now to get x by itself, I'll have to take 2 theta and subtract pi over 4. So the column just to the right is 2 theta, so now I need to take pi over 4 away. So that's going to move the whole graph pi over 4 to the left. So 0 minus pi over 4 is negative pi over 4. Okay, then if we take pi over 4 away from pi, we end up with 3 pi over 4, and then we're going to end up with 7 pi over 4, and then 12 minus 1, we get 11 pi over 4. And you can see we keep going up by, this was a -1, so we keep going up by 4 pi over 4. So the next one will be 15 pi over 4. All right, so what is it that's going to be graphed? It's going to be the X column versus the Y column. So let me just do this down below. Okay, so I'll make a nice little graph. And we're supposed to just graph one cycle this time. Okay, so the directions don't want us to graph a continued sine function. It just wants to do a single cycle of it. So let me put in a line right here. Okay, so this will be 1 and -1. All right, and if I were to go forward, it looks like units of about, so let's go, oh, let me put pi right here. This would be 2 pi, 3 pi, and 4 pi. And back here would be -pi. So I'm making every 2 units another value of pi. Okay, so let me go to plot the points now. -pi/4, well, pi/4 would be half of a unit to the left. In this case, it's -pi/4, 0. The first point goes there. Second point is at 3/4 of pi, or 3 pi/4 and 1. So that goes all the way up to there. The next one is at 7 pi/4, so just short of 2 pi, and that's back down to 0. And then if we go over to the next one, just short of 3 pi, we're down at -1. And then just short of 4 pi, we're at 0 again. So that's what the curve would look like. Let me pencil it in. Okay, so if I kind of sketch it in by pencil, it's going to look something like that. And the instructions are to just do one cycle. So let me ink that in now. Kind of gives me the pencil lines, give me a guide. So it looks something like this. Now let's compare that to a cycle of the sine functions. Well, a sine function by itself would go from 0 to 1 to 0 to -1. So if I go with the original coordinates, it looks something like this. Okay, so that's 1 pi cycle. All right, so we can see that it is stretched out. Okay, why is it stretched out? Because we have this multiplier. Just change colors here. Let me pick something interesting like purple here. Okay, this makes it, that half makes this oscillate half as fast. Okay, so it's oscillating at half the rate, so it's going to take longer to go through a cycle. And then this plus pi/4 is our phase shift. That's what the text is calling it, and it's going to end up being the phase shift of pi/4 to the left, because it was plus pi/4. So we're going to slide the other direction, pi/4 to the left. Okay. So notice what would happen is we would actually, if we did this backwards, okay, the first thing we had to do was double the theta values, and then we did the shift. Okay. So the stretch happens first, and then the shift happens second, because we have to undo everything that happened on the inside of that sine function. Okay, so that's how you can do these problems. So do the same thing with the set that I've given you for homework.